here. Okay, here we go. So this one says, and again, you want to have your formulas, you want to have that formula sheet, and I will try to maybe get it into a sheet form for you so you can have it digitally. But if you have your trig book, open it up to that front inside cover or back cover, I think it might be in your trig book, and all the formulas are there in one place. It's very explicit. It's going to say in the instructions, use product to sum or use sum to product, okay? Because those are the two things that we are doing today. Okay, so literally it says product to sum formulas, use product to sum. So I'm matching those two things up and I'm going to apply the formula that goes, okay? I have 4 formulas in this chart. So 1, 2, 3, 4. And literally I have to figure out, is it sine times sine, cosine times sine times cosine with the sine first, or cosine times sine with the cosine first? Because it makes a little bit of difference in the way we set this up. So looking at this first one in example 16, which formula am I going to use? 1, 2, 3, or 4? What do you guys think? 1, 2, 3, or 4? Help me out in the chat. In the room, you guys can just say it out loud if you want. What are we thinking? 1. Good. All right, I'm seeing a lot of good things. We are recognizing that we have to use formula number 4, the cosine times sine. All I'm literally going to do is write that down. The u would be the sine of the 5x, and the v is going to be the 4x. So I'm going to write down 1/2 sine of u plus v. And sometimes I'll leave that out. I just write the skeleton first, minus sine of u minus v. And I like parentheses versus brackets. Okay. All right, that's just my thing. All right, I'm going to plop in my u, which is 5x, and my v, which is 4x, and my u, which is 5x, and my v, which is 4x. Okay, now I'm just going to, all I have left to do is combine some like terms here in the middle. So 1/2 sine of 9x minus sine of x, because 5x minus 4x is x, and we're done. That's it. You believe it? That's it. Yeah, there's some right back here. That is it. Nice, right? Compared to what we did yesterday. Yesterday's was a little bit tougher than that. Okay. On example 17, I'm going to change the problem a little bit because something was coming up in the homework that I want to make sure that we understand before I let you out in the homework. I'm just going to take it, I'm going to put a 4 in front of this thing. So I'm changing the problem to 4 cosine 2x cosine 4 theta. Sorry, cosine 2 theta cosine 4 theta. Okay, so I just put a 4 in front. That doesn't take away from what formula we're going to use. So we're going to look at this first. Okay, so looking at our formulas, am I going to use 1, 2, 3, or 4 on this one? So which one? 1, 2, 3, or 4? What do you think? Okay. All right, it's looking good. It looks like we all recognize 2. So what I'm going to do is this 4 that I added into the problem, I'm going to drop that down, put it in parentheses. I am going to fill in problem or formula number 2. So 1/2 cosine of u minus v plus cosine of u, I don't have enough space. Wishful thinking there. U plus v. Okay, and then I'm going to drop in my u, which is cosine 2 theta, and my v 4 theta. 2 theta, 4 theta. That's a 4 theta. Let me move it a little bit so you can read it. Okay. All right. On this one, I'm going to blow it up a little bit more. So right here, look at these two things right here. Can't I cancel the 2 into the 4? It's just a coefficient out front. So that adding that 4 in is going to just change our coefficient out front. People were getting it wrong during first period, so that's why I put that in there, because I didn't have any examples like that. So I would say that we're going to get a 2 out in front, and then the parentheses. And let's see, we're combining like terms on the inside here. So cosine of -2 theta plus cosine of 6 theta. Technically, there's parentheses around it. Sometimes we're lazy and we don't write them. Now, there's one other way that our answer could get adjusted here, okay? So back at the beginning of all this trig stuff, we learned about the even and odd identities. And I know I don't have them in front of me. If you're here in the classroom, you can see them up on the green sign, okay? So if you remember how we had the pics, I took the picture of all the signs. Well, on our even odd identities, it says that the cosine of negative u equals cosine of u. Meaning that if I have a negative on the inside, it just becomes cosine of whatever the angle is on the inside, cosine of the u, because it's an even identity. Like sine of negative u has a negative in front. So some of them have a negative in front, some of them just go, the negative just goes away. So this piece here gets replaced with cosine 2 theta. And then the rest of it just stays the way it was, 6 theta, and then a 2 in front. And now I've got probably as final of an answer as we're going to get on that one. All right, one more of this type. So we're going to do sine of x plus y cosine of x minus y. All right, I'm going to scroll back up to my formula. So I've got sine times cosine. Sine times cosine. Which formula am I going to use? 1, 2, 3, or 4? What does everybody think? Which one? I want to hear from everybody. Make sure you're helping out. Brian, make sure you're working in the chat or answering me out loud. Okay, so it looks like we're going to do number 3. So 1/2 sine of u plus v, sine of u minus v. All right, so I start by just writing the skeleton of the formula. So let me go 1/2 sine of u, I'm going to leave myself some extra place, plus v, and I think it was plus, right? I totally forgot it, plus, and then, no, it was, yeah, and then plus, and then the sine of u minus v. No, yeah, am I right? I totally lost it. We're doing number 3, yes, plus and then minus. So plus sine of u minus v. All right, so my u and my v are a little bit different this time. This is the u, this is the v. So anytime I'm going to do the u, I do x plus y for that. Then I'm going to plot my v in there, x minus y. And then this one, whenever I have a negative, I always am very careful to put parentheses in front of it. Okay. So in this part right here, we look like we can combine like terms. What do we notice happens? What do you guys think happens in that section right there? What are we noticing? We've got x plus y plus x minus y. What are we wanting to do in there? Yeah, good. I'm waiting for my chat at home. What do we think happens? Okay, we are going to combine like terms. When I combine like terms, does anything happen that we kind of like happening? There we go. We've got the y's. Ariana, you were right. The y's cancel. Perfect. Okay. So your y's are going to cancel out. I'm still going to have this 1/2 in front, so I'd get sine, and then x plus x would be 2x. And then back here, what I'm going to do is I'm going to distribute that negative in. So it would be negative x, positive y. So in this case, in the back, the x's cancel, so I get sine of 2y. And that's my final answer on that one. Again, the trigonometry piece wasn't that difficult, right? We just had to apply the formula. It's the algebra piece. And I 100% guarantee next year, calculus is easy. It's the algebra that's embedded in the calculus that makes it challenging. That's the part we struggle with. All right, we're going to move on to another type of formula. So again, I have formula 1, 2, 3, and 4. This time we are going from a sum, meaning an add or a subtract, and we're going to go to a multiply, okay? So, and it should be pretty obvious. This one could kind of get mixed up with our sum and difference formula, so you got to be careful a little bit. Sum and difference looks more like this, sine of u plus v. So do you see how it's one piece of trig versus two pieces of trig? So this is the one we learned where we did the little chant. This one is the sum to product over here. Okay, so again, I'm just going to apply the formula that I see. All right, so I have sine 3 theta plus sine theta. So sine plus sine, which formula am I going to apply, everybody? Put it in the chat. I heard it. Good job. All right, we've all got that down. We're very good at matching things. Did you guys play that game when you were kids where you had to flip over and match the cards? You all would be very good at that right now. All right, so we have, let's see. I always like, again, I like writing the skeleton of the formula. So I know it's 2 sine of u plus v over 2 cosine of u minus v over 2. And then I know that this is u and this is v. So I'm going to plop those in. So 3 thetas for my u and theta for my v. And then we're going to go ahead and do some combining like terms and some canceling. Okay. So 2 sine, let's see, 3 theta plus theta would be 4 theta over 2. Cosine 3 theta minus theta would be 2 theta over 2. And then hopefully you're noticing the 2 goes into the 4 twice, so I get sine of 2 theta. And the 2's cancel, so I get cosine of theta. Done. Like 2 to 3 lines of problem. That's not so bad. It's not like 10 like there was the one yesterday that was kind of ugly. But we need an ugly one once in a while. Once in a while. All right. Looking at example 20. Example 20 is cosine plus cosine. So which formula am I going to use? 1, 2, 3, or 4? Okay, good. All right, I'm liking what I am seeing. You guys remember the one that looks like a little fish? That's alpha. Okay, that's what we call that, is alpha. So I'm going to write the skeleton of my problem here. So it is 2 cosine of u, I'm leaving myself some extra space, plus v, and then cosine of u minus v over 2. All right, my u and my v are a little bit different. Here's the u is alpha plus 2 pi, and I'm going to put that in both, plus 2 pi, okay? And then v is just alpha. And in this case, because there was only one term, I didn't put parentheses around that after the minus. All right, let's combine our like terms and see what happens. So 2 cosine, let's see, I've got alpha plus alpha would be 2 alpha plus 2 pi. I wrote my 2 goofy. It looks like the alpha, doesn't it? 2 alpha. And this is all over 2 still. Should have done bigger parentheses. Cosine, let's see, what happens with this alpha and this alpha? Good. What happens, everybody, with alpha and alpha? Yeah, they cancel out. Perfect. Okay, so we just end up with 2 pi over 2. So there's a couple of ways I could go from here. Okay, this here cancels to just cosine of pi. So we know that that's cosine of pi. And we're just going to leave it as cosine of pi. I know we could get our unit circles out. There's a number of ways, 2 different ways I could deal with what's left in here. Okay, so what's our very first rule of factoring, everybody? It's our first rule of factoring. What do we look for first? Always. Yeah, you guys are more on top of it than first period was this morning. They couldn't come up with that. All right, I didn't ask the question the same way though. I probably asked the question better in here. So we've got to take out a GCF. What's my GCF out of that numerator right now? Yeah, we've got a 2. Good. So 2 alpha plus pi. All right, so these cancel. So our final answer would be 2 cosine alpha plus pi cosine of pi. Now, I'm going to show you a second way. Okay, and either one of these works. So first period, the one student who was sitting here with me in the room's like, oh, that seems so much easier to just do the GCF. They thought that was the easier method. But about 15 years ago, my students couldn't do that for some reason or another. So there was another way we could do it. So the other way to do it is 2 cosine. I can split this into 2 separate fractions. So 2 alpha over 2 plus 2 pi, not alpha, 2 pi over 2, and then still cosine of pi. So the 2's cancel that way. So 2 cosine of alpha plus pi cosine of pi. So if you're strong at factoring, the other way is a good way to go. Okay, if you struggle with the factoring but you understand how to undo the fractions, this is a good way to go. Both of them get you to the same place. Okay. All right, are we excited? Because guess what? That was our last example that we're going to do of the school year. You can cross out all the rest of them. Should we celebrate with some confetti? Yeah. Yes. All right, we'll get out the confetti. I don't do messy confetti, though. I just do digital confetti. There we go. So last examples of the year. All right, so from here, what